Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about solving linear systems by graphing and also solving linear systems algebraically. Right, so let's get started. It's a pretty quick lesson. Right, solving linear systems by graphing. Let's talk about terms and definitions. A system of two linear equations in two variables consists of, believe it or not, two equations in the following form. We've got ax plus by, so two variables, is equal to some constant. And dx plus ey is equal to some constant. So we have the same variable, x and y. So we have two of the same variables in two equations equaling to some constant. So an example would be number 1, 3x minus 5y is equal to 9. And equation number 2 is 2x plus 8y is equal to 7. All right, so a solution of the system graphically is just the intersection of the two lines. So if I were to graph the two lines, 3x minus 5y is equal to 9, and 2x plus 8y is equal to 7, it looks something like it does below. And then my solution is going to be the intersection of those 2 points. So the intersection would be this point right here, and that's my solution. So a solution corresponds to the points where the graph of equations intersects, and it's going to be an ordered pair, so it's going to be an xy solution. Right, well, how do we solve this algebraically? We might be getting a step ahead of ourselves, but we'll go ahead and take care of an example, and then in future sections, we will also solve algebraically as well. So we have a system of two equations, x minus y is equal to 9, and 2x plus 8y is equal to 6. And we want to figure out where these two lines intersect, or if they even intersect at all. Okay, so what we're going to do, step number 1, is to solve one equation for one variable. So in this particular step, I'm going to solve for x in terms of y. So what I do is I'm going to add y to both sides. I have x, this really should be x plus y is equal to 9. So x plus y is equal to 9, and 2x plus 8y is equal to 6. So I solve for one equation for one variable. I'm going to subtract y from both sides. So now I have x is equal to 9 minus y. Then I'm going to substitute the value of that one variable. So I figured out that x is equal to 9 minus y. And I'm going to substitute that value, 9 minus y, back into the second equation for x. So I get 2 times 9 minus y plus 8y is equal to 6. And now I'm going to solve for that second variable y. So I have 18 minus 2y plus 8y is equal to 6. Minus 2y plus 8y is equal to 6y. 6 minus 18 is equal to negative 12. And then I divide both sides by 6, and I get y is equal to negative 2. So again, first step is to solve one equation for one variable. So I have x is equal to 9 minus y in terms of the other variable. And then I use that value that I get for x in terms of y, and I substitute that value, 9 minus y, in for x in the second equation, and I solve for y. Now I have y is equal to negative 2. Now the final step is to use the value of y, again, to solve for x. Well, I know that y is negative 2. I know that x is equal to 9 minus y. I can figure out what x is going to be. So I can either plug it into or substitute it into the second equation or the first equation, doesn't matter. In this case, I substituted in for y in the second equation. So I have 2x plus 8 times negative 2, because we figured out that y is equal to negative 2 as part of this system of equations. So 2x minus 16 is equal to 6. 2x, now we add 16 to both sides, is equal to 22, and then x is equal to 11. So we found in this case that the ordered pair is going to be 11, negative 2. Right. One other bit of information that you need to know about linear systems and graphing linear systems is that we can classify the systems in really 3 different ways. One is if the lines intersect at one point. One is if the two lines coincide, they're actually the same line. And the other is if we have two parallel lines and they never intersect. So lines that intersect are going to be consistent, which means they have some point of intersection, and independent, which means they are not the same line. Then we have lines which coincide, and those are going to be consistent, which means they intersect, and they're dependent, which means they're the same line. Or we have inconsistent lines, which means that they're parallel lines. So 3 different versions of systems of 2 variables. One is if the lines intersect at one point. One, and those are consistent and independent. So consistent meaning they have some point of intersection, and independent means there are 2 separate lines. One is consistent and dependent, where they intersect at every point, or they intersect at least one point. That's consistent. And dependent, which means they're the same line. And inconsistent, which means that they're 2 parallel lines. Right, that's the end of this lesson. I told you it was going to be quick. Come back and join us for some practice problems on Otten Math and solving linear systems by graphing.